Homework 10, section 5.3, independent events and the multiplication rule, video 6. Now that we've defined what independent events are, both ideally and in terms of numbers, probabilities, let's look at the multiplication rule for independent events. If A and P are independent events, it's kind of implied, but I'm going to write the word anyway. If A and B are independent events, then the probability of A and B equals the probability of A times the probability of B given that A has occurred. Wait, that's the exact same multiplication rule that we had earlier, regardless of whether or not A and P were independent. So why do independent events get their own rule? Oh, look at this part. If two events are independent, it means that the probability is the same whether or not this condition is on here. So if these are independent, I could call this the probability of B given that A has occurred, but since they're independent, it doesn't matter that A has occurred. So I can remove that and just call it the probability of B, a much simpler rule. If events are independent, then their joint probability is the product of their individual probabilities. And by the way, this extends to more than two events. So a more general multiplication rule for independent events is if A1, A2, AN are independent events, and when I say independent, I mean pairwise. If you pick any two of them, they're independent of each other. Then the probability of A1 and A2 and and AN, in other words, the probability of all of those events happening is just their individual probabilities multiplied. The probability of A1 times the probability of A2 times all the way down to the probability of AN. Sorry, I ran out of room there. It might have fit, but I'm not going to risk it. So as long as you have independent events happening back to back to back to back to back, you can find their joint probability by multiplying their individual probabilities. For example, let's say you flip 3 coins. What is the probability? Probability. They are all tails. So in other words, we're figuring out the probability that we get tails on the first coin flip, and probability of tails on the second coin flip, and probability of tails on the third coin flip. Are these events independent? Does what happened on the first coin flip affect what happens on the second? No. And neither one of them affect what happens on the third. A coin doesn't have a memory. It doesn't go, oh, last time you were heads, so next time you must be tails. No. Each flip is independent, which means I can find the probability of all 3 of them being tails by simply multiplying the probability that the first one is tails times the probability that the second one is tails times the probability that the third one is tails, because they are all independent events. Each probability is 1/2, and if you multiply 1/2 3 times, you get 1/8, or 12.5%. So anytime you're conducting an experiment that has multiple steps back to back to back, and those steps are independent, then you can just multiply all of the independent probabilities, all of the individual events' probabilities to get their collective joint probability.